Hey guys, Marshall from Segway. Today we're going to be taking a look at the Speech API on the Loomo SDK. So the Speech API is broken down into two modules. We have the Recognition module and the Speaker module. Today we're going to be focusing on the Recognition module. This will allow us to define voice commands with custom grammar, and then we can make those voice commands lead to certain actions for Loomo. Today we're going to be pairing the Speech API with the Locomotion API so that we can control Loomo's movements with voice commands. So let's go ahead and go into Android Studio. I'm going to make a new project here. I'll start with an empty activity. So I'm going to go ahead and name this Loomo Speech Example. Again, the name here doesn't matter. Just make sure that the API level supported minimally is API 22, Android 5.1. We're going to go ahead and finish. Okay, we'll wait for that to build. Okay. So in order to use the base class like we did last time and to use the recognition class, we're going to have to import those dependencies into our build Gradle. So navigate to the build Gradle for module app. And below all of these included dependencies, we'll add some Loomo dependencies. So we'll go over to Setup Developing Environment page on developer.segwayrobotics.com, and we'll grab first the Speech API dependency. So we'll grab that, throw that in there, and we will also get the base dependency. Put that in there as well. Okay, with those in there, we will sync the Gradle. Okay, with that done, let's navigate over to our main activity. This is where we're going to define all the logic for voice commands and base controls. So the first thing we need to do is grab a recognizer, declare a recognizer object here. So we'll type in recognizer. We'll select that it's from this package that we just imported, com.segway.robot.sdk.voice. Okay, so what that just did when I clicked that is actually imported that package in here to make sure that we get the recognizer from the correct package, because there are other classes with a name similar to recognizer. So need to make sure it's from Segway. Okay, so I'll go ahead and name this. So we'll declare that. And we need a base for this as well. Here you can see it's asking me to import that class, so we'll import that class. Okay, and we will name this imbase. So name that imbase. Okay, so we have our onCreate method. This is what runs when the app is first launched, first created. So underneath all of this, inside of the onCreate method, we need to go ahead and initialize our objects. So initialize the base. We'll go with the base class, we'll get an instance. We will do the same thing for the recognizer. Get instance. This will initialize these objects so that we can then bind them. So that's the next thing we need to do, is set up the listeners. So we'll make another function, call this init listeners. Okay, inside here we need to define the listeners that will listen for the binding of the services for the base and the recognizer. So here, let's go ahead and let's go actually to the top and make a bind state listener for each of these. So we will type in bind state listener. I'll hit tab to complete. That will give me the class, and I will call it imRecognizer bind state listener. The name here doesn't matter. This is just so we can follow along with the logic, and it will make sense when we use it. We'll get the other bind state listener for the base. So everything on the Loomo SDK, as far as the APIs go, use bind state listeners to listen for the binding of a service. All of these commands that would be passed through work through services, which is a fundamental component of how Android handles operations. So with those defined, let's go ahead and initialize them. So we'll take the recognize your bind state listener. We'll say it is a new bind state listener, tab to complete. That will give us all of this auto completed. Okay, with that defined, that initialized, we will also grab the base bind state listener. Here we'll do the same thing. Type in service bind listener. Okay, a tab to complete that. Okay, that will give us that object as well. Okay, the next thing we need to do here is fill out what happens when they are bound. So with our recognition state listener, what we need to do is we're going to have some grammar defined. We're going to have some grammar that allows us to define what Loomo is listening for. So you can see here, let's go back over to the SDK page. Let's go down to speech. Okay. So you can see here, Loomo can, you're giving him a grammar constraint filled with slots. Slots you can think of like parts of a sentence. So here, what we can do is we can have slot 1 defined as a word like turn, and then slot 2 or 3 defined as a word like left. And that together will produce a certain voice command that Loomo, that we can set to do some additional logic, like turn left will add a checkpoint that makes Loomo turn left. We can do certain things like that. So that's what we will be doing today. Okay, so let's go ahead and make some grammar for Loomo to listen for. So what we'll do here is go down and define a new function. We'll call this init grammar. And I already am anticipating that some of these functions that we'll be calling will throw an exception, or possibly could throw an exception. So we'll go ahead and explicitly throw that exception on this method. Okay, we'll go here, and we need to define some of the logic for the grammar. So first things first, what we'll be defining is movement grammar. So grammar can be anything you want, any sort of sentence you want Loomo to listen for, right, with a variation in words. So I'll define, let me go ahead and define a new slot. So slot, again, is like each individual word that's going to be used, or each individual part of speech with several words, like turn / walk. So either of these is acceptable for this slot. So let's go ahead and make the slot. Press Alt Enter to import that class. Okay, so we'll go ahead and call this first slot. It will be a new slot, and we'll just give it the name first. Or actually, probably more clearly, we'll call it movement. Okay, so we've defined the first part of the sentence that Loomo will listen for. So we'll add some words for Loomo to specifically listen for in that first part of the sentence. So we'll say first slot, we'll add a word. Here we'll add word move. So now Loomo on this first part of the sentence will be speaking. One of the words Loomo can look for is move. So we'll add another one in case we want to say something like go. So if we want to say go left or go right, so that'll be another first word that Loomo could listen for. And additionally, we'll add turn, since we'll be doing some turns, and we will also add rotate, since we'll be doing some rotations. Okay, so with those defined, so that's, again, you can think of that like the first part of the sentence, and these are the words that are valid for that first part of the sentence. We'll add another part of the sentence, another slot. So we'll call this second slot, just so we can logically follow that. So we'll initialize it, new slot, give it the name direction. So we're looking for a movement command, or a movement word, and a direction word. So we'll add some words to the second slot that are valid. So we'll add forward, for instance. We can also add backwards. So we'll say backward. And we'll also add left, and we'll add right. Okay, so now we kind of have our grammar defined. So we have our first slot, first part of the sentence. We'll call it movement. It can listen for these 4 words. And the second part of the sentence will listen for these 4 words. And so if it hears any combination of this first section and this second section, here's any valid combination, then it will result in a recognition, and then we can do things from there and actually define Loomo to move in certain directions when we hear those words. So next we have to make a list of these slots to actually put them together. So we'll make a list of the slots, and we'll call it movement slot list. Okay. Oh, I need to press Alt-Enter, import that class for list. Okay. So this will just be a new linked list, and we will go ahead and add these slots onto this list. First slot first, and then we'll add the second slot. Okay, with those added, let's go ahead and go to the top and create a grammar constraint. Go up here, create a grammar constraint, and this will be the object that we actually pass in to the grammar recognizer. So we'll just call this movement grammar. Call that movement grammar. So we'll go back down here, and on these lines we will go ahead and initialize the movement grammar. Say it's a new grammar constraint. Name it movements, and pass in the movement slot list. Okay, so that is the grammar object now. And last thing we need to do is get to the recognizer, get the method add grammar constraint, and add that constraint. Okay, now the grammar is in. So what we need to do is this function, init grammar, we need that to happen on the im recognizer bind state listener. So on bind, we need to initialize the grammar. So that will run that function when it is bound. And here we're getting a, except we need to go ahead and throw this into a try catch statement so that we can catch the exception explicitly. So voice exception E, okay. Here we don't need to do anything, so we now have that. Go ahead and build to make sure that all works correctly. So the next thing we need to do is go to our onCreate method again and go ahead and, now that we have the bind state listener set up, we'll go ahead and bind the services on creation of the application. So we'll do imRecognizer bind service, and we'll give it the application context, and we will give it the bind state listener that we've defined for it. And we will do the exact same for the base. Bind service method, get application context, and we'll give it the base bind state listener. Okay, now that that's done, let's go ahead and finish up filling out the bind state listeners and adding some additional listeners to the init listeners method. So first, after we've initialized the grammar, what we're going to have to do is start the actual recognition. So we'll pick one of these. So namely, there's start wake up in recognition. This will require us to use a wake up word first, like OK Loomo, and then use our voice command that we've defined with the grammar. So that's start wake up in recognition. The other mode we might use is start recognition mode. This will only listen for the voice commands that we've defined with our grammar. So that means as soon as we launch the app, as soon as the app is launched, it will listen for the commands we've defined, like move left, move right, rotate left, move forward, that sort of thing. So wake up it's nice to use because it actually has to listen for a wake up word before it starts listening just for everything. So it's perhaps better to use that to begin with. So we'll go ahead and use that method here. So for this method requires us to have a wake up listener and a recognition listener. So those are the two other listeners that we're going to define right now. So I'll go ahead and comment out this line, and we will go inside, anywhere inside of the init listeners method, we'll define these other listeners. So what we will do is we'll go to the top of our file and go ahead and make some member variables. Namely, we need a wake up listener, like I said. Call that im wake up listener. Okay, and we also need a recognition listener, so we'll make a recognition listener. Okay, so we defined those. So now we'll initialize them inside of the init listeners. So we'll go here underneath our recognition bind state listener, and I'll start with the wake up listener. Wake up listener, we'll say it equals a new wake up listener. I'll tab to complete, and that will auto-complete that, what that function is with the overrides for these individual functions. So we won't actually touch the wake up listener. I'm going to go ahead and minimize it just so I don't have to scroll through it. And we will use the recognition listener here. And we'll go ahead and initialize it as a new recognition listener. Tab to complete. Here, this function right here is where we're going to define all the logic for handling the different combinations of the words we added to our slots for our grammar. So we'll go ahead and do that. So we'll open this up, we'll get a new line, and what we're going to want to do is from the recognition result that it hands us from this function, we are going to define a string called result, and we'll get it from the recognition result. We'll get the actual recognition result. There's a few other things that come off of recognition result, including confidence and different things like that. So we're just interested in what was the string, what were the words spoken by the person. So we'll get those here, and we'll first define our rotation. So we defined in our grammar, we listen for the word rotate. So what I'll say here is, if the result contains the word rotate, we are going to do some sort of special checkpoint, some sort of checkpoint for rotation, right? And right now I'm just going to comment in these, and we'll go back and fill them in. And underneath here, if they've said rotate, and if they've said left, for instance, then we obviously need to rotate left. Rotate left. So else, if the result that has rotate also contains the word right, or rotate right, then we're going to need to do some action to rotate right. So here we're going to be using checkpoints on the base system. In order to flesh these out, what we need to do is first further define what happens in the bind state listener for the base class. So I'm going to unbind for this, and what we will do is add a few different things. So namely, we're going to use the base class, the base object we've defined. We're going to go ahead and set the control mode to navigation. The base.control mode navigation. This is because we're going to be using checkpoints, and checkpoints requires that the control mode be set to navigation. So that's the first thing we'll do. Okay, now the second thing to do is to set up listeners for the checkpoint system. So we'll say add checkpoint, actually it might be set checkpoint listener, set on checkpoint arrive listener. Go ahead and do that, and we'll hand it a new checkpoint arrived listener. So we'll go ahead and throw that in. Okay, now that we have that all set up, let's go back and fill in what happens on the recognition result inside of the im recognition listener. So first, we don't need to do anything if it just says rotate. For our two special cases here, we will add checkpoints here. Now, to rotate around, we actually want to move 0 in both x and y directions. But then in the theta, which at checkpoint can take 3 variables, it can take the x, y, and the theta, if you see over there. So the theta is the angle. So for the angles are all defined in radians. And if you need a refresher on kind of how to define radians, let's look up unit circle. And we can see here, if we think about this, let's go ahead and open this up maybe in a larger view. So this is the unit circle. So if we think of Loomo at 0 degrees, how he is initially oriented, and he's facing this direction, then to go left, we need to rotate 90 degrees, which would be pi over 2 in radians. And if we want to go right, we need to go 270 degrees, or 3 pi over 2. So our right will be 3 pi over 2. Our left will be pi over 2. So go back to Android Studio. So our theta for this, we use the math class. We'll grab pi. And since we're going left, we are going to need pi over 2. So we will just say math.pi over 2, and we'll go ahead and convert it to a float. So we'll cast it to a float here. So we'll say that that's a float. Okay, and then we're all good for that. And then for rotating right, if we say rotate right, then we'll add a checkpoint. We'll go 0 in either direction, since we just want to rotate in place. And for our angle, back to the unit circle, we need 3 pi over 2. So I'll say 3 times pi, get pi from the math class, and then I will divide that by 2. And additionally, we need to make sure we cast this to a float so that we get the correct value, since at checkpoint it takes all these values in as floats. Okay, with that done, we didn't just define rotate, we had some other words in there. We had move, go, turn. So for these other words, I'm going to think about it like if we say any of these other words, we're asking Loomo to go in one of these directions, 1 meter. So that's how I'm going to define it for this tutorial. So if instead of rotate, the result contains move, or we can specify or by doing this double pipe, or result contains go, or result contains turn, then we're going to do some other type of movement. Okay, so we'll specify some cases for moving in certain directions. So if the result contains forward, then we are going to want to add a checkpoint that moves Loomo 1 meter forward and 0 in the y direction. Else, if we want to move, if we want Loomo to go backwards, and we say backwards, then we are going to specify a checkpoint that moves Loomo -1f in the x direction and 0f in the y direction. And we'll do the 2 other cases. So if result contains left, if result contains left while we say a word first, like move, go, or turn, then we're going to add a checkpoint that instead moves 0 in the x direction and 1 in the y direction. 1 meter in the y direction. Okay, and then our last one will be if result contains right. Okay, that we're going to add a checkpoint 0 in the x and -1f in the y. Okay, so that's our cascading list of different checkpoints we do under different conditions. So now that we're done with that, the next thing we need to do is make sure that when these are called one after another, if they are, that we're not saving the same or origin point every time. So For instance, if we said move forward, Loomo went forward 1 meter, and then we said move left, right? So if we said move left after that, Loomo would be trying to go back to the 0 position in X direction. So it would go backwards. It would actually go backwards, and then it would go left 1 meter as well. So that's a different position than just from where you are, Loomo go left, which is what we want. So in order to make it every time Loomo stops and then we tell him to go another direction, it goes in that actual direction. We need to reset the origin point each time we call one of these checkpoint statements. So to do that, we're just going to define a new method here. We're going to call it base origin reset. So this will reset the origin point every time we call the checkpoint command so that it can be interpreted as a kind of a scalar versus a vector. So what we'll do here is set control mode. We'll just make sure this control mode is set every time to navigation. We will call the method clean origin point on the base class. We will, before we do that, actually, we will, let's see, first thing we want to do is clear all checkpoints, clear checkpoints and stop, then clean original point. Then we need to make another pose, so we'll make a new pose called the new origin point. We'll get the pose from the base class, we'll get the latest, the base class that we have, the object we have. We'll get the latest odometry pose, -1 to get the latest. Okay, we need to, oh, I spelled that wrong. Yes, there we go. Okay, and then we need to set that as the original point. So we'll call set original point, and we'll pass in the new original point that we got. Okay, so we'll call this method every time. We'll call this function every time that we use our checkpoints. So to do that, we will go up to our checkpoints, on recognition result, and every time on recognition result is called, we will go ahead and reset the base origin point. So on recognition result is called every time there is a correct recognition recognized, some combination of the grammar that we've defined, every time that a correct combination is found, that will be called. So let's go back up. So we'll call this every time, so that when we use the checkpoints, the origin point is set right before we call one of these checkpoints. Okay, the next step is we're going to fix a few things. So I put in backwards here. We're actually going to fix this to be backward, because in the grammar we defined, in the initialize grammar method, we defined one of the direction words as backward, the singular use of the word. So we're going to make sure that our conditional statement lines up with that we use backward. Also, we need to add a semicolon here. I see that that is erroring on the file. Okay, so that works now. Now we need to complete the recognizer bind state listener. So we'll go ahead and uncomment this, and we need to put in the listeners that we just finished up defining, the wake up listener and the recognition listener for the recognizer. So we'll put in those two. Recognition listener. Okay, no, those two are in. We are also going to go back down to the base bind state listener. Inside the on checkpoint arrived, I also want to call the base origin reset. So if it arrives at a checkpoint, just for redundancy's sake, I'm going to call this. So now that that's all good, everything should be ready for us to move on and create a view so that we can remember the grammar that we've defined, so that when we're using the application, we know what to say. So to do that, go over to the res file, go to the layouts, activity main. Okay. So when we open the app, this is visually what we will see. Now, we have all the logic for moving Loomo with voice commands now, but this is what we'll actually see on the app. So we want to change this slightly so that we can remember what to say. So we'll go to our values. We'll make a new string in the XML. So we'll define a new string on the strings.xml file underneath the values folder. We will name it main text. And we're going to go ahead and say okay Loomo to get started. And we will go ahead and add 2 new lines here. Next thing we want to say is choose a phrase. So, and then we want to say our options that we've defined in our grammar. So this is, again, just for us to visually be able to see on the screen kind of the options that we have. So I'm going to put in, we said the words move, /go, /rotate, /turn. And we also said the other options are left, right, forward, backward. Okay. Let me add some new lines here so those separate. And we'll go ahead and take that text view component of the view, and we're going to go ahead and go at, and then we'll do string, and then main text appears right there. So we'll type that. Let's see, make us type it in. /main text. Okay. There we go. So we'll make sure that this is in the middle of the view, and everything should build correctly. Okay, and one thing to fix before we install our application onto Loomo is we need to add, we need to actually call the init listeners function here before binding to the services, so that the listeners that the services that listen for the services to be bound are set and initialized before the bind service method is called. So after that, we'll rebuild, and we will deploy the application to Loomo. Make sure Loomo is, of course, plugged in and in developer mode. Okay, and now we'll go over to Loomo and make sure everything works. Okay, so we've deployed the application to Loomo, and it should load up like this, showing us the view that we just created. And so it's ready to go right now. So I'll say, okay, Loomo. Okay, Loomo. Move forward. And we'll see it moves forward. Now, if I say, okay, Loomo. Okay, Loomo. Move backward. So now Loomo will rotate around. It doesn't actually go reverse. It will go backward, though, in the backwards direction, just facing forward. So now if I say, okay, Loomo. Okay, Loomo. Move backward. So we'll just get it to go around again. And you can see that, of course, we're calling the base origin reset method before we do a checkpoint. So it is using the actual directions. So now I can say something like, okay, Loomo, turn left. And it will turn left. And of course, I can even interrupt it while it's moving. Okay, Loomo. Okay, Loomo. Turn right. So turn right. Make it turn right again if we want. Okay, Loomo. Turn right. Takes that 90-degree turn, goes right. Okay. And so you see that I'm saying okay Loomo each time to launch it. That's because we use the start, wake up, and recognition mode. We have to use wake up words like okay Loomo before we actually use the grammar that we've defined. So that's how to use this application, and we'll go back and discuss a few more things. So that was how to use this application and get it all the way working. Now, say instead we don't want to say the wake up words. We don't want to say okay Loomo every time we want to launch our recognition system. So we can, instead of this method, we can replace this method with only the recognition mode. So we'll do imRecognizer, start, and we'll use the recognition mode. And we'll just supply it with our recognition listener. Now, we do need to change our recognition listener slightly to obey this kind of thing. So what the wake up listener does is if we error on our recognition listener, if it doesn't hear something that's defined by our grammar system, then it will just go back to the listening for the wake up words. So if we're just using the recognition listener and we error, right now how we've defined the recognition listener, this will just kick us out. It will return false every time. So if we send it a correct result even, it will exit out of the recognition. It won't listen for new recognitions. So if we want it to listen for new recognitions, even if it errors, or if we tell it to turn left and then we want to tell it to turn right later, we need to set these to true. So that's what we'll do here. We'll set these to true. And now every time while it's running, it'll just run continuously and listen for new commands all the time. So I'm going to go ahead and build and send this version to Loomo and we'll check it out. So we've loaded up the new version of the app just using the recognition listener, not the wake up. So we're not waiting on wake up words like OK Loomo to launch. So it's continuously listening for what our input is. So now I'll just choose a phrase. If I say go forward, go forward. Now Loomo will go forward towards me. If I say rotate right, Loomo will rotate to the right. If I say I did it again. Rotate left. Rotate left. Rotate left. Rotate left. Rotate left. Rotate again. So it can do the same sort of phrases that we've defined before. Another thing to note though is since we didn't add any unbind method to when we close the app, you will still see this running if we close the application. So I can still say turn right and it will still work. So if we want to avoid this behavior of it constantly running until it either shuts off, or destroys the app, we will need to add something to the on pause or on destroy method. And we'll go back to Android Studio and do a little bit more of that. Okay guys, so we're just going to change a few things that will make this run better. So I found that using 3 pi over 2, like is defined in the unit circle, sometimes Loomo will rotate all the way around 3/4 of the circle. It will still face the right side, the side that it would face if it went right, if it just went straight to it. But I found that it's much more reliable if we switch this to -1 times pi over 2, so it's negative pi over 2. I found this is it performs much better. So the next thing we need to change is we need to add some life cycle. We need to handle some events on the life cycle of this activity. So when I close this application, I don't want this continuously trying to listen for what I'm saying. So what we want to do is we want to add a few methods. We want to override the protected method on resume. We want to add some functionality to when the application resumes. So instead of us binding the services on the onCreate class, we'll do it on resume. We'll do it in the on resume method. This is because every time the application starts or is started from, maybe you're in another application and you go to this application, or you're just in the main launcher on developer mode, every time we launch the app, onCreate is called one time, right? But onResume is called every time it comes from a different app or something. So if we call it in onResume, it will get called no matter what. So it's a better place to put these 2 lines for binding the services. So we'll do it there, get rid of that. The next thing we want to do is every time the application is closed, we want to make sure that we're still not listening. So what we want to do is override the on pause method, and we'll go ahead and do what it tells us to do. And we will take our objects and we'll unbind them. We'll do unbind service on both the recognizer and the base. Do unbind. Okay. Now if we did that correctly, this will allow us to manage the life cycle of the application much better. Every time we close the application, it will stop listening, stop moving, and every time we restart the application, resume, or start it from nothing, it will bind the services correctly. Okay guys, so that's been how to control Loomo's movements with voice commands. We've used both the Locomotion API that we learned in the last video with the Speech API, specifically the recognition module. Stay tuned for the next tutorial guys, and have a good one.